Have you ever looked up at the night sky? Of course you have. You see a velvet black canvas sprinkled with a few thousand twinkling points of light. It feels peaceful. It feels vast. It feels dark. But here's a thought that might keep you up at night. If the universe is infinite, or even just mind-bogglingly big and filled with countless stars, then the night sky shouldn't be dark at all. In fact, it should be blazing with the intensity of 1,000 suns. Every single point you look at should eventually land on the surface of a star. The darkness you see, the very thing that defines our night, is one of the deepest and most profound mysteries in all of cosmology. So, what's the big deal? The big deal is that our simple observation, that night is dark, tells us something fundamental about the very nature of our universe. It's a clue, hiding in plain sight. It whispers secrets about time, space, and our place within it all. Why isn't every direction we look a brilliant, unending wall of starlight? Let's travel back in time. Not billions of years, just a few centuries. A German astronomer named Heinrich Olbers stared at the same dark sky you do. But it bothered him. A lot. He formalized a question that had been kicked around for a while, and it became known as Olbers Paradox. Imagine an infinite universe, uniformly filled with stars. If you look in any direction, your line of sight must eventually end on the surface of a star. Think of it like standing in a truly endless forest. No matter which way you look, you see a tree trunk. You don't see any gaps. Now apply that logic to the cosmos. If stars are the trees, the night sky should be a solid wall of light. Distant stars would appear fainter, sure. But in an infinite universe, there would be more and more stars the farther out you look. The sheer number of stars at each greater distance would perfectly cancel out the dimming effect. So, the total brightness would be overwhelming. The night sky should be as bright as the surface of the sun, yet when we look up, we see black. This is the paradox. Here is the first major clue to solving Olbers' paradox, and it's a big one. The universe is not infinitely old, it had a beginning. We call it the Big Bang. Our best measurements tell us this cosmic birthday party happened about 13.8 billion years ago. That might sound like an eternity to you and me, but on a cosmic scale, it's a finite number. This fact, the finite age of the universe, is a game changer. It means that we can only see the light from stars and galaxies that are close enough for their light to have reached us in 13.8 billion years. The universe has a horizon, not of space, but of time. Think of it like this. Imagine you are in the middle of a vast dark ocean, and a single lighthouse turns on 13.8 miles away. You wouldn't see its light instantly. You'd have to wait for those photons to travel across the water to your eyes. Now imagine lighthouses are winking into existence all over the ocean at different distances. You will only see the ones whose light has had enough time to complete the journey. The light from any star farther away than 13.8 billion light-years simply hasn't had the time to get here yet. The universe isn't just sitting there, it's expanding. Think of raisins in a baking loaf of bread. As the dough expands, all the raisins move farther apart from each other. This expansion has a profound effect on the light traveling through space. As light from a distant galaxy journeys toward us, the space it is traveling through stretches. This stretching of space-time also stretches the wavelength of the light itself. This phenomenon is called cosmological redshift. Light that may have started its journey as visible, energetic blue light gets stretched out, becoming lower energy red light. If the galaxy is far enough away and moving fast enough, that light can be stretched all the way out of the visible spectrum into infrared, microwaves, and even radio waves. Our eyes can't see these forms of light. This combination, a finite age and an expanding universe, delivers the 1-2 punch that knocks out Olbers' paradox. While cosmic dust wasn't the ultimate solution to Olbers' paradox, it still plays a major role in shaping what we see. Our own galaxy, the Milky Way, is a pretty dusty place. Thick, opaque clouds of gas and dust known as nebulae are scattered throughout its spiral arms. These are the stellar nurseries where new stars are born, and they also act like cosmic curtains. When we look toward the center of our galaxy, our view is almost completely obscured. We can't see the brilliant, tightly packed core with our naked eyes. The light is blocked. Then there are the voids. The universe is not a uniform soup of galaxies. On the largest scales it looks like Swiss cheese or a cosmic sponge. Galaxies are clumped into long filaments and massive clusters. In between are vast, almost empty regions called cosmic voids. These voids can be hundreds of millions of light-years across, containing very few, if any, galaxies. Point your line of sight into one of these deserts and there's simply nothing there to see. Now let's talk about the things that don't just block light but actually devour it. I'm talking about black holes. These are objects with gravity so intense that nothing, not even light, can escape their grasp. They are, without a doubt, the universe's ultimate traps. When a massive star dies, it can collapse under its own weight, squeezing an immense amount of matter into an infinitesimally small point, a singularity. A black hole is, by its very nature, perfectly black. It adds no light to the sky, it only takes it away. They are the ultimate cosmic light sinks, forever removing potential sources of illumination from the night sky. The universe isn't just a static collection of stars and galaxies, it's a dynamic, violent, and ever-changing place. Galaxies collide, they merge, they tear each other apart. When two galaxies merge, huge clouds of gas and dust are compressed. That compression triggers a massive burst of star formation. But the intense burst can use up a galaxy's gas supply quickly. Once the fuel is gone, star formation grinds to a halt. The galaxy fills with old, red, dying stars. No new, bright blue stars are being born to replace them. There are other, stranger phenomena. Consider the mysterious green bean galaxies. And then there are ultra-diffuse galaxies, UDGs. They can be as large as the Milky Way yet contain only about 1% of the stars. Beyond the galaxies and stars, there's another reason for the darkness. A census of objects we are only just beginning to appreciate. Think about planets. For most of human history, we knew only a handful in our solar system. Now, thanks to missions like the Kepler Space Telescope, we know planets are everywhere. We have confirmed thousands of exoplanets, and data suggests there are more planets in the Milky Way than stars. But here's the thing. Planets don't produce their own light, they only shine by reflecting their parent star. From interstellar distances, that reflected light is incredibly faint. It's like spotting a firefly next to a searchlight from miles away. So for every bright star you see, there's likely an entire system of dark, unseen worlds orbiting it. And it gets even darker. We are discovering a huge population of rogue or orphan planets. These were ejected during chaotic formation, now drifting alone through cold, empty space. They have no sun, no starlight to reflect, completely dark and incredibly cold. Current estimates suggest billions or even trillions of these lonely wanderers. They are ghosts, silently floating through the cosmic night, utterly invisible unless a chance gravitational lensing event reveals them. These unseen worlds, both orbiting and rogue, add a profound sense of mystery to the darkness. When you look at a dark patch of sky, you are not looking at empty space. Your gaze may pass through regions filled with countless dark planets, brown dwarfs, failed stars not massive enough to ignite fusion, and other cold, non-luminous objects. The majority of objects out there don't shine. The darkness hides the true population of the cosmos. So we return to our original question, why is the night sky dark? The answer is not one thing, but many. It's because the universe had a beginning, and the light from the most distant stars hasn't reached us yet. It's because the universe is expanding, stretching the most ancient light into invisibility. It's because our view is blocked by cosmic dust and punctuated by vast, empty voids. It's because light is consumed by black holes, and because galaxies can run out of fuel and fade away. And it's because the cosmos is teeming with dark objects, planets, brown dwarfs. The darkness is the story of everything. This simple observation, available to a child looking out their window, unlocks the entire history and structure of the cosmos. The darkness is not a failure of the universe to be full, but a testament to its grand, unfolding narrative. It speaks of birth, expansion, evolution. It whispers of hidden objects and unseen forces. The darkness is as informative, as profound, and as beautiful as the light. It holds the secrets, the mysteries, and the answers to questions we haven't even thought to ask yet. This is what makes science, and especially astrophysics, so compelling. The greatest mysteries are often hidden in the most familiar phenomena. It is the nature of the human mind to question, to be curious, to not be satisfied with night is just dark. We look for the deeper meaning, we build the telescopes, we formulate the theories, we push the boundaries of knowledge. The darkness of the night sky is not a barrier, it is an invitation. It's a challenge from the universe to us. Here I am, it says, come and figure me out. And so, the search continues. With every new telescope, every new discovery, we peel back another layer of the darkness. We find new surprises, new puzzles, and new reasons to be in awe of the cosmos. The next time you find yourself under a clear, dark sky, take a moment. Appreciate the darkness. Appreciate the profound story it tells. And let your curiosity run wild. What other secrets are hiding in that beautiful velvet blackness? What will we discover next? I invite you to share your own thoughts and wonderings. Because in the end we are all stardust, trying to understand the night.